Welcome back to another episode of the MSDN show. In today's episode, we're going to talk about soap. No, not that kind of soap, although I realize there's probably a few of you out there that need to take better care of your own hygiene. No, today we're going to talk about SOAP, the Simple Object Access Protocol. This is the way that applications can take and expose their interfaces on the web so that other applications running on the web can see what's going on. So we're going to learn all about that, but first let's go check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. In November, Microsoft released the Nile.com Sample Bookstore application. The Nile.com Sample application is an e-commerce product catalog and online transaction application developed for the PC Week and Doculab's benchmark competition. The benchmark tests show how different architectural decisions can affect scalability and performance of a web application. The three implementations used for the benchmark application include Visual Basic with ASP pages, Visual C++ with both ISAPI and COM+ components, and one using all ASP pages with no compiled components or code. In December, the MSDN Architectural Samples team released the online website, source code, and several architectural articles for the design and deployment of an N-tier distributed web application called Wiechers Online. The design articles provide developers with the trade-offs and choices they made while developing the e-commerce application. The deployment articles detail the network architecture used for the Wiechers Online web server farm. In December, Microsoft announced the release to manufacturing of Microsoft BizTalk Server 2000. BizTalk Server 2000 allows the orchestration of business processes and web services within and between organizations. Microsoft also published the final version of its BizTalk Framework 2.0 specification. The specification provides a general overview of the BizTalk Framework 2.0 conceptual architecture and specifies the outline of BizTalk documents and messages. Also in December, Microsoft released the first beta release of the Microsoft SOAP Toolkit version 2.0. The SOAP Toolkit 2.0 is a fully supported replacement for the current MSDN SOAP Toolkit for Visual Studio 6.0, which has been available for several months. While the version 2.0 toolkit offers functionality similar to the MSDN SOAP Toolkit, it is a completely new product with several new tools and features required to implement a web services infrastructure with SOAP. It is designed to be compatible with the new WSDL specification supported by the .NET Framework and Visual Studio.NET. Be sure to check out the show transcript for links to more information on these news items. And that's been the MSDN News Update. I'm Erica Wiechers.
Here to talk to us about some of the architectural aspects of SOAP are Dave Reed and Andrew Layman. They're going to take and help us understand why SOAP exists and what it can do for programmers and how it might affect the aspects of developing applications for the internet, for the web, or even for inside your own company. Well, thanks for joining us.
Welcome.
Now, Dave, what exactly do you feel are some of the important aspects that SOAP brings to the table in the scope of the Microsoft technologies that are coming out?
Well, I think there's many interesting aspects. The thing that comes to mind, first and foremost, is the fact that it enables really building heterogeneous systems, where in the past we would be focusing on proprietary protocols, or if we were doing some type of heterogeneous interop between two different types of infrastructures, say between COM and Corba, we'd have some kind of point-to-point kind of integration that did work but was painful to build, and often even when you were targeting standards like Corba, you would really have to target a specific orb and then do interop with, say, Iona or something of that nature. SOAP and XML as well has really changed the industry in a fundamental way, and that fundamental aspect is the fact that you have many competitors that get together within the context of a standards body, the W3C, agree on something like SOAP, which is really a protocol wire specification and then build products around those technologies that now allow this seamless interop between the two. That to me is the most fundamental thing. From an architectural standpoint, there are major differences from the types of systems you can build using a technology like SOAP versus which we refer to as a loosely coupled technology as compared to some of the technologies such as DCOM, such as RMI, et cetera.
But using a more proprietary connection between services and like that, you gain the fact that you know the structures, you know what you're talking to, you know the platform, you get a lot of speed from that. Aren't we giving something up by creating this more open-ended sort of thing?
Well, I think the answer is sure, if we could pull it off. But one of the characteristics of the internet is that you've got millions and millions of people. You've got systems that are deployed and changed and re-provisioned over time. It's just flat impossible to accomplish that. And I think that you can push with a system that says you're going to gain interoperation among systems by somehow getting them all to run exactly the same software. And that's been an approach that's certainly been tried. It's being tried by some people right now. But when you scale up to something of the dimensions of the internet, when you have people able to install software on computers without checking with everybody else on the planet, then I think it's just hopeless to think. In fact, it's just a very foolish battle to fight to try to say that the way that we're going to get heterogeneous systems to interoperate is all get them to run the same software. No, I think what we need to do is accept that people are going to, in a very decentralized way, version, upgrade, redeploy significant changes to their software. And that one of the key issues is, how do we build a system so that this can go on, where it's just part of the design criteria of building a system, that you're going to have to face this problem up front and say, heterogeneity, right out the go, and you're not going to be able to have a single administrative domain that covers the whole internet. Okay, if there's no administrative domain that covers the whole internet, how do we face this? How do we deal with this? And the answer is, we're going to build something that relies on protocols, that have extensibility built right in. That's where the X in XML stands for extensibility. That's why SOAP is built on top of standards such as XML, such as the Universal Resource Identifier specification, all of these things that are designed to allow extension without having to rely on a single administrative domain.
If I can just elaborate a little bit more on your, I certainly agree with everything that Andrew said. I get a lot of, when I talk to customers, a lot of questions like, well, I've architected my system in such a way I expect certain performance criteria associated with how I put that system together. I'm doing transactions, which is really kind of a tightly coupled thing, doing two-phase commit transactions with a database. Am I going to want to be, putting SOAP in all those different aspects of my system? And the answer to that is, well, I start with the caveat is that where SOAP is today and where it is tomorrow are certainly two different things. Today, SOAP works best on the edges of various architectures, edge servers per se, where you're communicating with other systems, even if it's behind the firewall, you have a heterogeneous environment and you need to communicate with that system. As Andrew points out, it's basically impossible to do that today without something like SOAP, so that's enabling new types of situations. Yes, people have cobbled together their own infrastructures, et cetera, but SOAP allows to do this. Is it going to replace, TDS or those kinds of protocols that exist between the data access layer and SQL Server? The answer is no. Okay, so when I hear your question, saying, well, with the proprietary nature and the tightly coupled nature, et cetera, and when you mention performance, I hear you concerned about whether SOAP just is going to ripple everywhere through the architecture, and the answer is no. But we have to remember, this is where SOAP is today, and tomorrow it could be a different type of thing as we do compression, as we do binary XML, those types of things where SOAP becomes more performant over time.
I guess it kind of reminds me of, in the early days of programming, people would write either their applications in assembly language or in a application or compiled language like C, and they would always think, well, gee, the fastest way I could do it was going to be an assembly language. But over time, the compilers got better and better to the point that the compiler could almost be as fast, if not faster, in the assembly version, just because the compiler really understood how to take and tune the code properly. And so you're saying that SOAP, over time, will take and improve, and the infrastructure of the internet will improve. So maybe today, we're getting some small performance hits that we'll notice, but we'll just improve those and make them better?
Yeah.
Yeah, I think
Except that assembly language, I don't think is a fair comparison because, I mean, it's an interesting comparison on the performance side, but unlike, say, like if you're comparing SOAP to DCOM, I mean, there are things that just DCOM can't do, you know, whereas assembly language, you can virtually write anything.
Right.
Yeah, I think it's a
Okay.
bit of a trap when people think about performance. And performance is certainly incredibly important. You have a problem, you want to run it faster with fewer resources, but it's not the end goal. So if you start rejecting certain valuable problems as saying, well, that's a customer problem that we're not going to solve because we can't make it run really fast, then you've missed the point. The point is to solve customer problems. And like HTML solved some customer problems that some far more efficient systems had just rejected as being not interesting to solve. So I think that the important thing is not to ask, is XML as fast at solving certain things, but to ask, does XML and SOAP solve important problems that people have? And when you get to internet scale and you get to heterogeneity, I think that performance is extremely important. But it's not the first question to ask. The question is, what do we do about building heterogeneous systems? Then, given that we've got a good technical solution, now how do we make that thing really run?
So the benefit there is heterogeneous solutions, talking to different computers, having a standards-based method of communicating across these different systems. And,
Right.
And
I think to paraphrase, SOAP is enabling new scenarios that were not possible before with these tightly coupled protocols, but it's not necessarily replacing where the tightly coupled protocols really excel today, like between a database and the middle tier, for example.
are we seeing people actually deploy solutions that are creating these heterogeneous solutions, getting a Linux system, talking to a Windows system, talking to a Macintosh or something like that?
Yes, and I would even say it's better than that. Because let's say you look at something like what Ford has done. They've built a system where they can communicate with their suppliers who sell them parts. 50,000 different suppliers. A lot of suppliers that the guy who built the system at Ford has probably never met. Now, it isn't that the guy at Ford says, I want to know that I've communicated to a Windows system, to a Linux system, to a Solaris system. He says, I'm going to put together this specification for the kind of messages that we send. And I'm communicating to your web service, Mr. Supplier. And I cannot tell whether that was written on Windows or written on Linux. So,
And you don't want to tell.
and I don't want to tell. And why? Well, if it's Linux, because I'd like to come back and sell them an NT box in a year, you know? And I want to be able to make that sale and have that thing upgraded. But from a customer's point of view, they may say, well, maybe it was a Windows box, and we want some flexibility here in what we run. From Ford's point of view, they want this whole thing to keep running when some of their suppliers are running some things, some others, and it's going to be a variety. And that's another thing we just have to face and build systems that can deal with it.
Now, is SOAP something that someone for the Linux system needs to provide, and is Microsoft providing SOAP for Linux or Solaris or so forth?
Yes and no in terms of providing it. SOAP is a wire specification. It would be like saying, does Linux need to provide TCP/IP? Or does Linux need to provide HTML? Technically, no. It's just a spec for what the bits are on the wire. But if you want to be an efficient programmer, you're going to want to have a lot of supporting code. You're going to want to have things that make it very easy to generate that XML, those SOAP messages. And so as a programmer, you'll probably find that you get a lot more work done every day if your platform allows you to do most of these things with very few lines of code.
So then, talking about the very few lines of code, there's been a kind of a constant theme within all these .NET episodes I've been doing. Where exactly does SOAP fit into .NET? I mean, so far it sounds like it's just this protocol that we're going across the wire. Does .NET work with SOAP, and how soon does that appear?
When I think of .NET, I think of three things. Well, there's many things associated with .NET, but probably the first thing I think of is the whole loosely coupled architecture. And I think that's one of the most important concepts to really get associated with building, architecting, designing, and writing the .NET application. Web service is a loosely coupled thing. You call it in a stateless fashion. You call it using an XML-based protocol, SOAP. You call it with an XML payload. and the receiving end of that is very flexible in terms of how it's architected and the types of APIs it's exposed. There's not a tight coupling between how you call the thing and the types of methods and APIs and et cetera that are exposed there. XML produces, if you could say, a level of indirection between those things that gives a lot more flexibility there. So loosely coupled is the first thing I think of, and then I think of SOAP and XML as the underpinning technologies that really enable this loosely coupled architecture. So I don't really differentiate between .NET, XML, and SOAP. I think they're all kind of I mean, SOAP and XML are really is the underlying architecture of .NET. In the implementation of .NET, specifically in Visual Studio .NET, SOAP is the protocol that is used to enable a web service. It's the protocol that's used in the object remoting infrastructure that's built when you call another object. Yes, there are other protocols supported as well, but for certain scenarios it makes a lot of sense to use SOAP. The type of interoperability that the .NET architecture offers is enabled through XML SOAP, which is the discussion we just came off of. So, I think it's a very, very important component of .NET, and you really can't separate the two.
So we've totally embraced SOAP, and another system like an IBM system like that, they may not necessarily use .NET, but they can still use SOAP. They can talk to our .NET applications.
Absolutely. In fact, it's as Andrew mentions, SOAP is a wire specification. It is currently, I mean, Andrew probably should talk more about this at some point with respect to what's happening with SOAP right now in the W3C.
But IBM is one of the co-authors of SOAP.
IBM is one of the co-authors of SOAP, as well as a few other companies. So it's an important part of supporting SOAP to ensure interoperability. The way that you do that is you, number one, pay close attention to writing to the specification, the SOAP 1.1 specification, but also, we have test teams within Microsoft. I have a test team for the SOAP Toolkit version 2.0 that we're working on. There are conformance test organizations in Visual Studio .NET where we test each other's SOAP implementations, but we also test IBM, Developmentor, and other SOAP implementations that are out there to ensure interop. And and there's a community of people that work back and forth to identify potential problems, and obviously the thing that we use to decide where the error might be is to take a look at the specification.
Mm-hmm. Well, Andrew, why don't you talk a bit about W3C and where SOAP fits into that?
Okay. As Dave alluded to, one of the important things about SOAP is that there is a definite specification. And so we're not talking about getting a couple of products to interoperate by testing those products against the other. We're talking about something more along the lines of HTML. There's a definite specification. If issues arise, the first place you look is, well, what does the spec say? And then hopefully you adjust your product so that it actually matches that spec. Now, the specification for SOAP is actually a fairly small, fairly tightly bounded specification. It isn't everything that could be done with XML messaging. And there's a range of things, a range of ambitions that we have, of things that we believe ought to be done in a very broad, horizontal, industry-neutral, vendor-neutral way using XML for messaging. But the core of that is the core features that have been identified in SOAP. Specifically, the crucial thing about XML, the thing that made XML so successful, that makes it so useful for documents, is that it has a rich structure and an extensible structure. And by extensible, I mean that you can invent tags. If you, for a business need a tag that isn't part of a specification, didn't come from a vendor, didn't come from Microsoft, you can actually invent one of your own. Between XML spec and this facility we call namespaces, you can make up the tags to do what you need. We wanted to apply that same concept to a protocol. And essentially that was our goal in designing SOAP, is to say, let's look at this success factor on XML and say, how can we apply that to a protocol? Well, one of the first things you want to do is you want to use XML. But now, because of a protocol, you're dealing with people who may have to communicate without having a prior agreement among them, there were a few more things we had to build in, such as if I send you a message and maybe there's some parts in it that I know are optional, others that I know are vital, maybe you and I haven't negotiated beforehand how you're going to deal with those, well, I should put into my message something about, if you don't understand this part, you can ignore it, versus if you don't understand this, it was too crucial, you better just reject that message. Applying about that level of extensibility control, we've built a very small protocol. It's just a base. It handles one issue only, and that is extensibility. Once we have, however, a specification that handles extensibility, then we can work with the W3C, and we can work with other parties and say, what are some other things that need to be done? Now, the specific status of SOAP at the W3C is SOAP has been submitted as an input to an activity that the W3C has called the XML protocols activity, which is at the process, as we're taping, is in the process of defining its requirements, working out what are the features that need to be in the very basic protocol. And I'm pretty confident that SOAP is a very good fit for those things. So we have very good confidence that an investment in SOAP is almost certainly to be a very good investment in XML protocols.
Well, because SOAP's already gone through a fairly large process of dealing with a bunch of different companies. Who are some of the other companies that have been working on SOAP?
Well, some of the early ones were Developmentor, and Dave Weiner put a lot of work into it. Probably the biggest name in there outside of Microsoft would be IBM, but we've worked with Iona, we've worked with Hewlett-Packard, we've worked with too many for me to accurately remember, and I'm sure that there's somebody who really deserves a lot of credit and has just gone completely out of my mind.
But all these names are like in the SOAP specification itself. And I'll make sure in the transcript I include a link to that SOAP specification.
Yeah, at the W3C.
Yep, you can just go
right.
to the W3C, and it's the SOAP 1.1 specification that's out there.
So from an architectural standpoint, let's say there's some people in our audience right now that are thinking about implementing some services and getting some designers working on putting these things together. What do they need to think about in their service structure and how they prepare it on their systems and get their programmers excited and energized for developing these applications? Is there something they need to think about different than a normal service they might have?
SOAP is how you're going to expose programmatically how you interact with your application. Okay, so depending on the type of application that you're building, it could be used in a B2B style through BizTalk Server. BizTalk Server uses SOAP. And in that style of application, you're really receiving business documents. You're translating them into your internal format, which is XML, at least within the BizTalk domain. And then you're routing those documents to some either logic or potentially database records, etc. That's one style of application that would fit into the B2B world. On the web services side, architecting, there are lots of things that are new in VisualStudio.net, and we certainly don't have the time to run through all those things like web forms and ASP.NET, ADO.NET, and the XML frameworks that are in there. There's a whole bunch of new exciting programming model out there, each of which is going to have some effect on how you're architecting your application. For this particular discussion, we're talking about SOAP. So the first thing that you would think about is, I gave you one context, the B2B context, which frankly is pretty straightforward. Designing web services where you're doing some kind of programmatic API, I think the issue comes down to this is a very different type of API than you're probably used to with respect to things like defining APIs that are either just programmatic APIs that you're going to reuse in an object-oriented style, or potentially DCOM calls where you do have location issues where you got to think about if this is going to be a remote call, in proc, out of proc, of things like that. In the SOAP world, I mean, the thing that is probably closest to is designing out of proc DCOM calls, but that's just an object view onto using SOAP. There's also a style of usage in SOAP which is purely message-based. That is also, we believe, a very important aspect of SOAP.
I mean message-based, what do you mean by that exactly?
To really interact with an application in a message style instead of Really, the way you would characterize this is most of the demonstrations that we see in VisualStudio.net, you're basically generating a proxy on the client side and then interacting with that application as if it's an object, calling methods on that object.
Simply calling a
and
function.
Yeah, and actually under the covers, that's turning into a SOAP message, etc. When I say message-based API, that means that you're crafting up some XML either by manipulating a DOM or however you want to do it, and then you place that into a SOAP envelope and you actually send the message. And you could probably go into the efficiencies of doing that versus an object style. Frankly, there's been a raging debate within the company for many years, as long back as I can remember, between sort of an object-oriented view and a message view. At the end of the day, both are right. It's really how the programmer wants to interact and architect their application, and we support both, which is the good news.
So one of the things is that VisualStudio.net will allow you, if you want, to have a very RPC-like syntax, and it's a very convenient and efficient way for a programmer to operate. Or you can use the more expensive and somewhat difficult, but slightly more flexible manipulation of the DOM. Neither of those, though, exactly captures the difference between a more traditional object-based and a messaging-based system. So let me draw out some of the things that one should think about, which is not how you write your program. It doesn't say you write your program by manipulating the DOM or by calling methods, but it's a different perspective on how you're going to write on what your program does and how you define what it does. First off, when you're dealing with the internet, the expense of sending a message is usually very high. A message, it costs a lot just to package it together, get it out there, and it's going to take many milliseconds to get it across. And it's going to take a lot longer if it's going far away. So what you're
across a 28.8 modem or something like that. Yeah.
It's going to take a very long time. But even if you're running at the speed of light, but you're going to Europe, it takes a while for it to get there. You're going through switches, there's delays. So you don't have you have a lot more latency than you do if you're running in process on a machine where you're writing some sort of a user interface. So whereas if you were writing an application that was typically running on a personal computer and was dealing with user interface issues, you'd probably do things very fine granularity. That's probably the wrong way to do things if what you're doing is communicating with some remote partner over the internet. So you're going to have to rethink out what is the application and what are the large-scale communications that you're going to send him, which is one of the reasons why SOAP and XML is good, because SOAP is a packaging mechanism, XML is a tree structure plus potentially even a graph structure. So you've got the facilities. Let me draw a contrast. An old style of programming for how to get a purchase order put together. And given, let's say you were dealing with a purchase order system, you'd probably have a create purchase order method, an add line item method, an add product method that would add a product to the line item, etc. Don't do that on the internet. Because, think of all those calls going over the wire. It's crazy. What you want to do is might want to have some local methods that are like that. But what they're doing is not sending the message. They're just assembling a message on the client side. But when you're designing your app, I wouldn't think in terms of those assembly messages. I would think out, I've got partner A and I've got partner B. What are their roles? What are their business relationships? And what kinds of things have to be sent back and forth?
So much more of a B2B style interaction.
Yeah, it's much more of a B2B style interaction. Now,
yeah.
So think of it as you're sending a large document. Now, it might actually be a fairly small document, but think out, not how did I implement it, but what am I asking that service to do? Or if I'm writing a service, not how do I implement my service? That'll come in time. But the first thing to ask is, what are the functions that my service performs for people? What messages are necessary for them to send me? Preferably, what are the high granularity messages that people
bulk number of things you can do all at once.
Right. What can they send me send me a whole purchase order, send me a whole invoice,
Well,
send me a whole check payment.
yeah, if I could kind of paraphrase what you said, I think traditionally we've built systems where in an OO way where we design a bunch of objects and those objects have some call dependency. And when we distributed that type of application in the past, we may have just kind of distributed it, and some calls were in proc and some calls were out of proc and some calls were remote depending on where we put these various objects. In the new world, you can continue to design things in an OO way, but when it comes to how you communicate between these applications, or even between these two parts of a single application, but if it's in a remote way, think about it in a chunky style where you're not just doing procedure calls, but you're now thinking about, okay, I don't have great bandwidth here between these two things. What's the most efficient way that I can make this process jump, and what information should I package up to get the biggest bang for the buck? So in other words, this whole document is going to be passed over here, and I can just start the party on that document over in this other application, where in the past it would have been, you know, several iterations of calls to get over that information, because you really don't design internally to have these really large chunky objects. Is that?
Yeah. So let's give another example of like wrong way, right way. Wrong way. You don't want to do something where you start a transaction, take $100 out of this checking account, call another method to put $100 into the savings account, end the transaction, right? At that point, we've got 4 things going over the net, and we've got a lot of failure points. And you know, what happens if the second or third of those messages just flat gets lost? And that happens on the net. And that, which means that in order to deal with that, we end up adding a lot more protocol on top of it. Okay, so that's the wrong way to do things here. You know, great inside a data center, bad between trading partners. What you do want to do is compose a message that doesn't even say, change my bank balance from being from being $100 or $1,000, now change it to $900, and this other one that you say, oh, change it from being $900 to $1,000. You want to compose a message that captures the change that you want from a more business level, if you will, which is take $100 out of checking, put it into savings, regardless of what the balances are initially, or provided that none of them go negative. Make that change. So you're going to just send this message that says move $100 from checking to savings. That's the right way to do it. Now it's up to the receiver what methods he runs internally in order to carry that out, including what transactions he fires up. But don't put your transactions on the wire.
Okay. Well, thanks. Are there any last words that you think are important for someone in the audience to understand what SOAP really means to them?
Well, I'd like to say a few things about what we're shipping.
Okay.
We're shipping a few different implementations of SOAP, and I think at the time of this taping, we're about to go beta with what's called the SOAP Toolkit version 2.0. Today we have, today we ship a couple of things. We ship the visualstudio.net beta, which is accessible to anyone in the audience. I'm sure you've said that many times. And we also ship something called the SOAP Toolkit for Visual Studio 6.0. So the new thing that's coming out is the Toolkit version 2. It is a version 2 of the Toolkit, but it's a brand new implementation that happened out of the, it happened out of the SQL Server product team, out of my organization, Web Data. And our goals with this release is to have a supported product level SOAP implementation for people who today are using Visual Studio 6.0. The prior implementation was first built as kind of a prototype by some heroes. I say heroes because they really helped us get a SOAP implementation out there for our programmers to use, but it's unsupported technology, and right now it's really in its last release. So I just wanted to clarify to folks where they should use these technologies, and I have the following advice. If you're building a production system and you want to use SOAP, then you should be using what we're calling version 2 of the toolkit, the thing that's coming out of my team. So if you're actually using the 1.0 toolkit today and you want to actually deploy the technology that you're building, you really need to move to version 2.
Is that a lot of work to do that?
There's some amount of work, but we'll be providing help with that. Naturally, we would have loved to have had a completely seamless upgrade, but for a variety of reasons, we redesigned the API set for some extensibility reasons and APIs that we felt really promoted the style of usage, like the message style that I had referred to previously. And also, we're really serious about standards compliant, interop, et cetera. There are some things that have required us to make some changes, but we'll be providing help in that area. The second point I was going to make is if you're actually building a new app and you have deployment requirements that force you, say, to deploy in the next 6 months, then we also advise you to look at the toolkit, the version 2.0 toolkit. But really, most of our weight is behind visualstudio.net. You know, if you have these hardcore deployment requirements, look at the toolkit. But we really do, releasing version 2 of the toolkit is by no means a hedge or anything like that. It's a very it's something that we needed to do for our customers. We get a lot of customer demand today for deployments that they have to do, say, in the next 6 months. But it's important to remember that our strategy and where we have all our weight behind a single area is visualstudio.net. So if your deployment requirements are, say, longer than 6 months, and you have more flexibility in those types of time frames, or you're just prototyping, et cetera, you really need to be looking at visualstudio.net. So I just wanted to say that to try to reduce the amount of potential confusion that might exist there.
Thanks, Dave. Andrew, any last words?
Yeah, I would say that probably over the last few years, people have heard a lot about XML and have gotten the impression that it is the next big thing, or rolling the clock back. So, SOAP is obvious, or rather XML was obviously a very important technology, and now they're hearing about this thing called SOAP. Well, SOAP is, I think, the killer app for XML. Everybody's talked about how XML is going to glue applications together, but it's been a little nebulous how that was going to happen. And now SOAP is providing the answer to that. So SOAP is where we see XML delivering on the potential that it has.
Well, thanks. I appreciate talking to both of you today, and I hope you clarified some issue that our audience might have about what SOAP is and how they can use in their architecture. Thanks for joining us.
Thank you.
Welcome.
Well, that covers some of the architectural aspects of what SOAP means to an application developer, to system designers, and to web services in general. Hopefully you've learned some things you need. Now, there's still more of the show left, so stay tuned.
So here we are in the middle of our quest to pass along this wonderful propeller hat to Bill Gates as kind of the chief propeller head of the Microsoft Corporation. And we're at the Bell Red Barber Shop in Redmond, Washington. Let's go in and see if we can't track Bill down. Well, hello, Marvin.
Hey.
Hi, how you doing, man? Yeah, I'm Andy from the Microsoft Developer Network, and I'm in search of Bill Gates. I want to present him with this gold-plated propeller hat as the leading propeller head at Microsoft. And I heard a rumor that he might be here this afternoon for a haircut. Is that a possibility?
This is only June.
Oh, this is only June.
June, I think. Well, let me check the calendar.
Yeah, it says, what, June 15th or so?
Yeah.
But not today, I guess.
Not today, no.
Well, he's not here, but I wonder if I could just ask you a couple of questions
Sure.
about Bill. What kind of haircut does he really go for?
A rare haircut.
A rare haircut.
Rare haircut. He rarely gets one.
When he does get one, he doesn't really go for broke.
No. Mess it up, he says.
Uh-huh.
Cut it
Does,
uneven. He likes it uneven.
He likes it uneven. He
Uneven,
plans
yeah.
that.
He
Well,
plans that.
Does his image consultant come along with him to plan that, or
Oh, no.
does he come by himself?
Sneaks in after dark.
I hear you.
Yeah.
Uh-huh.
He looks a lot better after dark.
Uh-huh.
And the haircut looks better after dark.
Well, before we leave, are there any kind of historical spots here in the barbershop that you might want to show us?
These are the reasons why Bill comes in the shop. This is what's left of his petting zoo. This is the one that the one time the Mariners beat the Sox. This is the one he got at Hollywood and Vine. And this is the antelope he got in West Virginia. And of course, his all-time favorite, a cartridge and a bare tree. And this is the chair where Billy got his first haircut. This is the original apron Billy used. You can see it's like a little cowboy. Billy loved cowboys. As you can see, we retired the chair after Billy got his last haircut, along with the strap that we used to make Billy behave himself when he got his last haircut.
Well, we were unlucky today here at the barber shop. I guess we'll have to find him in another place. Marvin, can you tell me, do you know of anywhere else that we might be able to find Bill this afternoon?
Well, it's Wednesday. It's Women's Day. He usually plays golf.
And do you have the address out there?
I got a map right here.
All right, excellent. Yeah, I think I can find that. All right, well, thank you very much, Marvin. It's been very enjoyable. Thanks a lot. Take care. I'll stop by for my own haircut next week.
All right.
Hey, see you later, Marvin. Oh, what a guy. I think I'll be changing barber shops and come and get a haircut here next time. Well, we didn't quite find Bill at that location, but I think it's time to move on to the next one. We'll try to catch him at the golf course, see if we can't get him before he takes off on that first tee this afternoon.
Here to talk to us about the programming aspects of SOAP is Keith Ballinger, a program manager for the .NET framework. Now, how exactly does the SOAP fit into the .NET framework?
SOAP fits in a few crucial ways. The way that is most prominent is with web services. SOAP is also used in our remoting technology as well. But with web services, what we found is we needed a protocol that had a lot of vendor and industry support, and SOAP was there to create web services that allowed you to put these highly scalable, easy to program web services that could be called from any platform or any language that understood these standards like SOAP. And so SOAP seems like a natural fit from the very beginning.
So SOAP's actually providing some of the underpinnings that allows the .NET framework to talk to other systems, is that it?
Well, there's a whole feature set within the .NET framework based around the idea of remotely sending messages based on XML to other machines in an RPC-like way and in a message passing type of way for business-to-business communication, for business-to-consumer communication. It's really a great way to talk to other systems when you need to make a call that's not in process. And so SOAP really allows us to do that in a better way that has a lot of support within the industry, as opposed to creating our own XML protocol for sending messages.
Now, when you said out-of-process fashion, what do you mean by that exactly?
Well, usually when you have logic that you need to invoke within your application, oftentimes it's in a DLL right on your machine. However, there are times when you need to get data from another machine. You can't just ask yourself for the data. You need a stock quote, and that stock quote is on a partner's machine halfway across the world. If you can use standards like SOAP and XML and HTTP to make that call and say, request that data and get back the data you need, that's completely out of process with the actual process that your application is running in.
So it's not even just like a multitasking system running on the same computer, but you're taking an application's running here and an application's running on some totally different computer, and you're connecting the two via SOAP in the underlying protocols.
Exactly, and the application that they may be using may be an entirely different operating system, entirely different programming language that it was written in, a completely different platform set of APIs. But because we both agreed upon SOAP and upon XML and HTTP, this communication can happen in a very realistic and easy way.
But can something like a standard SOAP interface kind of be rich enough to supply the programming interfaces that you're needing in some of these high-end applications today?
A better question would be, can XML describe the data I need to send? Because it's very data-centric, and web services are very data-centric. SOAP itself is a fairly simple protocol. It says when you send a message and when you receive a message, here's the XML that you need to encode, that you wrap your data with, and then you can use XML for whatever is inside of that SOAP body, for instance. And so if XML is rich enough, which we've found is, for the past few years of using XML, the industry has found that XML can describe data in a really rich way, a way that is easy to use and that has a lot of tool set support and vendor support. And so really the answer is yes.
Mm-hmm. Now, as a programmer thinking about SOAP, Does it mean having to change the way you're writing your application? Does it mean having to write a lot of extra code on top of it to support this, or how does it fit in?
To build a web service with SOAP definitely changes the way you think about writing an application and the way you design an application. However, what we've done is we've created an API that makes it very simple, so that before, if you had to get data or send data to a remote machine, it would have taken a lot of code, it would have been an obtuse API, and it would have been probably very specific to your API set. With web services in SOAP, you can think differently because you can think in terms of chunky, stateless data communication. But at the same time, it's easier than the old, more tightly coupled RPC model that we used to see in the industry.
And how is it different exactly?
Well, one of the ways that is different in the way terms it makes you think is web services, and the way we use SOAP within web services is very stateless. We don't encourage, nor do we provide a lot of tools to activate an object on a remote system and then keep that object around and pass a reference of it around the network. We don't think in terms of those types and object references and whatnot. More we think in terms of chunky data. I have some data I'm going to wrap up in XML and send somewhere. That place that I'm send it to is going to send me back some data. Again, chunky data in a stateless manner. And this is a different way of thinking about things as opposed to I'm going to activate an object on the remote system. And it's a way that's much more neutral as to platform and neutral as to programming language and API and whatnot. And allows you to do just a richer set of things because you're no longer tied.
So the object that you're dealing with is constantly being kind of passed back and forth, and each person takes that and operates upon it and passes on to the next guy, kind of, or?
Not at all. But maybe an example would be the best way to show
Sure.
you what I mean.
Yeah.
So I have my computer right here, and I have a simple web service that I've called the test it web service. It has a single method that takes a string and returns a string. I want to show you the code for this web service. Let me open up a command prompt and go into the directory where this web service exists. And I've called it simple.asmx, and that is in no way simple. Let me write you one.
Okay.
So I want to write you a simple web service. And the way web services work within ASP.NET, within the .NET framework is, I have a file, just like a web page, a .aspx page, only this time I have an extension called .asmx.
And ASPX is for the ASP.NET functionality as opposed to ASP, which is .asp.
Well, ASPX is a web page within ASP.NET, a page that's going to show a UI that a user would interact with within a browser. The .asmx extension means this file is only going to contain code that's going to be exposed as a web service that will have to be consumed by something else, perhaps even a web page, and then somebody will write UI to show that data
there's no
off.
visual aspects associated with the page at all.
Not with a web service page. There is a helper page that we just looked at briefly, that ASMX page. Is a helper page to say, here's what I do, but you don't really interact with that page programmatically at runtime. That's more of a design type feature to show you the contract of the page, to show you the operations it supports and whatnot. So within this ASMX page, I give the web service directive just like I do the page directive in ASP Plus, or ASP.NET. I say my language is C#, and then I point to the class. I name the class that's going to be my endpoint in this SOAP message. And that class could exist in a DLL within this application's domain, or I can write the code right in here afterwards. So I'm just going to say I'm going to have a class called hello. I'm going to import the system namespace, and I'm going to import the system.web.services namespace. I'm using C# here, which is a really great language, and it's very quick. And I'm going to create a class called hello, which matches the class equals hello in the directive. And now I'm going to create a web method. A web method basically means that this method can be exposed as a SOAP operation. What we've done is we've mapped SOAP operations, sending and receiving a SOAP operation as defined in WSDL or in the SOAP message, the SOAP spec, to a method in the web service. So this one we'll call my method.
So using the keyword web method is like the hint to the compiler to do some of the special stuff associated with the method?
Yeah, the web method attribute tells the ASP.NET runtime and the web services runtime, not the compiler necessarily, that you can expose this method, and this method can take and return SOAP operations. And that allows you to reuse this code somewhere else within your application. You could write a DLL that has your business logic and just use it within your application. And then it may occur to you later, I want to expose this DLL, I want to expose some of these operations to my partners as SOAP because it's very standard and they'll be able to consume it and understand it. But maybe not all the methods, maybe not everything in this business class, this class full of business logic, do you want to re-expose? And so the web method attribute allows you to still have public methods that can be used from within your application, and the web method says, and this is actually public to the web itself.
So there's public and there's more public.
Yeah, there's public and web public, I guess you could say. So here's a simple method called myMethod, which is just going to return the string that it received.
You'll get rich writing code like that.
You will. This is a sophisticated sample. So we call string.asmx now from the browser, and we can see that this web service started up. And here's like a helper page for me to look at and say, oh yes, there is a method called myMethod that this web service exposes. And the most interesting part here is a link to the SDL contract. This is a beta 1 build of Visual Studio.NET, the .NET framework in Visual Studio.NET. In beta 2, we've switched to the more to WSDL because we're seeing a lot of vendor status. Some of the Microsoft programmers and some of IBM's people have worked together on this. But in the meantime, we're using SDL, and SDL or WSDL are XML files that describe the service in an XML way so that we can programmatically use it. So what do I mean by that? Well, from the command prompt here, or from Visual Studio.NET, I could consume this SDL and create a class on my client that acts like that class on the server, but in fact is creating SOAP messages and receiving SOAP messages. With the command prompt, I would just use web service util. I would say I want to create a proxy, and I would give it the path. In this case, I'm going to give it the path just localhost because I'm on my own machine. To that ASMX $SDL, I could just as easily have saved this SDL somewhere locally, and it would have, I could have given the path to there. So now it's going to create a proxy class for me called hello.cs, as we can see. If we open this up, we see this class is pretty simple. It was auto-generated. It's importing some namespaces for web services and XML serialization. It's called hello, and it has a myMethod that takes a string and returns a string, just like our ASMX page, just like our class here. The difference is that what will be sent over the wire when I invoke this myMethod call will be pure SOAP, just pure XML. There will be nothing Microsoft specific, nothing .NET Framework specific, nothing C# specific about this. The other end could have been a SOAP serializer built on an entirely different operating system with an entirely different language and a set of APIs. And it would work as long as it followed the description in that SDL.
So now, what you did there was you auto-generated the proxy code, and it sniffed out the web services that you had just got through exposing from your web method call there, and created a stub that you could use locally to call across. Is that what's going on?
That stub class, that proxy class, says I take a string and turns that into XML, turns that into the XSD, the XML schema string data type, wraps that up into a SOAP message that conforms to the SOAP that the SDL file that web service says it needs, and sent it to it. The ASMX page will get that SOAP, it'll deserialize it all, pull that string out from the XML, and then invoke myMethod, which will then return it. SOAP will be created again, sent to the client. The client will take the SOAP it has received back from the HTTP, from this call, deserialize that, and turn it back into a string and return from the function call.
So essentially, you could take and write other code now that would call this little function from this proxy stub bit and not even realize that SOAP was going to be used at all.
Exactly.
I've got this function, local function that I can call, and then the proxy code would be doing all of the serialization.
In many ways, it becomes an implementation detail. You don't have to specifically think about these things any more than you need to because we have these tools that encapsulate it for you.
Now, could you have also taken, let's say, you wanted to temporarily not use the web service, you wanted to do it all locally, and you knew what the algorithm was, you could have just changed that stub code to either do the algorithm that's being used on the web service to do it locally, and then put back in the SOAP code. And so the application that's consuming that little local function, then again, still has no notion whatsoever as whether it's a web service being called or whether it's just local processing being done.
Yeah, you could do that. Now, I would say if you need to invoke a web service just to run an algorithm, you probably don't need to make that a web service call. Web services are better really not just to return strings, but to get data that exists on that remote machine that you don't have locally. So if you just, if you need to calculate pi, you might as well do it in process as opposed to calling a web service. The web service is much better at exposing some key information that you don't have. And you can see an example of that. So let's create a little command line app. Let's call main. And this command line app won't do a lot. It'll just invoke our web service. And we'll have a main class called main app, and I'll create a static function called main that will do a very simple thing. It'll, if we look at the class created here, it was called hello. So what we'll do is we'll instantiate an object of type class hello, and then we'll write out to the console this method's return value. So in this case, we'll call it hello. We'll send it the word hello, and we see it's called my method. We're going to send it the word hello, and within this code here, it's actually going to go out and serialize this into SOAP, like I said, and deserialize it out of SOAP, and then return a string. So that's what that line will end up doing. And then we'll return. We'll save that. So let's go ahead and compile this. And I'm doing all this just with the command line. Visual Studio makes all this even more simple. To compile it, you just hit build, and it would know which DLLs to use and whatnot.
Sometimes you really like getting back to the command line. It feels better sometimes.
I like the command line tools, and I like to use Notepad. And I like to use these more simple things, so I know what's going on really underneath here. This proxy class, I can see it. I can see what it's doing. It helps me learn more. We'll compile everything, and now, as you can see, we have a main.exe. I want to run main.exe. It's going to, and here we see it just came back with hello. What it's done there, when that function was called again, was it made a SOAP call, and it sent it all the way to the server and sent it all the way back. And it was SOAP in between, and there was nothing Microsoft specific about it, like I said before. And so I have some other examples of this. I have a simple app here that I've turned logging on, and the logging code's a bit large, so I didn't want to show it all off. But we can look at this logging code is logging the exact SOAP that was sent and received. So here we see in this first, what I'm highlighting now, this is the SOAP that was sent and for a very similar method called test method instead of my method that sent a string. And we can see there's nothing in here that says Microsoft, there's nothing here that says RPC, it's very simple and easy to understand even if we just look at it. And here's the return from the server. Again, it's just XML. It's saying here's the result, and it's hello, it's SOAP, here's a body, in the envelope. It's, again, very simple to understand and can be used across multiple vendors and whatnot. So the more interesting things now is, what can we put there? What can we put within the SOAP body? What can we make? Here we're just invoking a method with a single string, but we can do much more complex data types with XML. We can create very structured XML that can contain very rich data, and not just strings or not just integers or floats.
It should be like a database of contact lists and stuff like that you were submitting to some company, and it was going to take that information and build a set of mailers that it would send out to all the people on your contact list with your Christmas cards or something like that.
Exactly. As a matter of fact, I have an example here called objects.asmx. I'm sorry, I should notepad instead of. Oops. Make sure I know what it's called here. Yeah, objects. Here I have a web service, and as you can see, it's more complicated now, but I have a method called test method that's going to create this address object and return the address object. And here we can see, here's the address object. It's not very complicated. It's just a class with 4 fields, and one of the fields has an attribute on it called the XML attribute, which will serialize this XML in an interesting manner. And if we call, I have a command line application that's going to call the service, get back the address, and just write out the street name, for instance, in this case. But now if we looked at that log file, if we look at the SOAP that is being sent here, we can see that the method was called and there's no arguments for it. But now if we look at the return value, within the SOAP we have a much more complex data type now. We have result, zip code equals 97603, street, a street tag, a city tag, a state tag. This is much more structured XML. Again, if you notice, this XML right here in no way is specific to the platform. It in no way is specific to .NET. A machine running Unix could just as easily understand this XML that came back and what it represents, which is obviously an address. Now if we notice here, the zip code in this address is an attribute in XML instead of a child element. That'd be very easy to change. Let me erase what's in our log file. And now let's change this as an X file here. This attribute, this XML attribute tag on this field said, when you return this class, when you take this class and turn it into XML, I want you to take the zip code and make it an attribute. Now that we've removed it, it'll become a child element. It'll become just another child element of the address class. So we can run it again. SOAP's being created, XML is being created, sent, returned, all the things we talked about before. And we can see now that the zip code is just another child element for that XML.
What would be some of the benefits of doing it as a child element rather than an attribute?
That's a kind of a design issue a lot of people have with XML. Some people like their XML to be lots of child elements. Some people like attributes. And generally, I would think that the zip code on an address would be more of a child element as opposed to an attribute. But some design guidelines I've heard people use are if the tag has a modifier on it, they can only have one of, it makes sense to have it as an attribute. So if you had some XML that was structured to be an address, you could see each of these things. There's only one street that an address can have. You could see that as an attribute. You could just as easily see it as a child element. But if you had more than one thing, so if you had a name element, if you wanted to list all the people who lived at this address, you couldn't do that as an attribute because you can only have the attribute once. So you'd really want as a series of child elements, maybe that is name, the name of a person living there, name, another name of a person living there. So that's just kind of how you want to structure your XML. And if you look at places like biztalk.org and other industry groups, they're creating these schemas that describe XML for various business-to-business processes. And that's kind of key to thinking with web services is if you can think in terms of the schema, if you can think in terms of the XML, the data that you want to send and receive for this operation, you can build a class like this address class with our tools or just on your own that can handle this XML. In a sense, we have a strongly typed XML capability within the .NET framework that's really key to this whole SOAP web services thing. The way we do SOAP, the way we handle SOAP descriptions and SOAP discoveries, all with strongly typed XML, so that our code's a lot less. And so when you want to return SOAP, when you want to return or build a SOAP service with the .NET framework, you don't really have to think about things like the SOAP envelope and the SOAP body. You can think in terms of what do I need to put in that body? Or what do I need when it's sent? What do I need to put inside that body when it's sent back? You think in terms of that chunky XML, that data, and then the rest of it kind of falls into place for you because it's a industry standard that we've done all this work for to make it easy for you to use.
So on the XML aspect of it, when the XML is being created locally, sent remotely, and brought back again, the application you're writing, you're developing that maybe doesn't even understand SOAP at all, it's really not even needing to think about XML, is it?
That's right.
It's just taking, like maybe it has a structure. That it says, okay, I'm going to have an address structure with a street element, a city element, a state element, a zip code element, and I'm going to pass it to this function to be your proxy function that you had here. That's going to then XMLize the request and then pop it across via SOAP.
Exactly.
And so XML is more like the transport layer.
It's a data description layer that you don't necessarily need to know about. How we describe data, say in memory, you don't need to know anything about. There was a time when maybe you did, and as the industry has progressed farther and farther along, we kind of encapsulate ourselves from these lower level things. And with the .NET framework, we have an API within the system.xml namespace for dealing with XML in a DOM-like fashion or in a reader-like fashion with things like XML Reader and XML Document. But if you know the structure of your XML, if you know the schema, you don't necessarily need to use those things. The XML knowledge that people feel they need to gain, maybe they don't need to gain it anymore, because with the XML serialization architecture that is key to web services, it's just like you said. I can think in terms of these objects with fields. I can manipulate things that way. I can just say address.street to get the street. I don't have to create an XPath argument. I don't have to go within traverse an XML DOM to find the street tag and then parse out the code. All of that's done for me, and now I have an object that I'm manipulating. Now, the key thing here is that I don't really care about the object. I care about the data. And so the XML is still the king thing. The schema is still the central piece to what's going on. But it's like you said, if I know what the structure of the XML is, or somebody can tell me what it is, I no longer need to do all this XML processing. And it's a powerful concept. I've seen web services that people have written where there are 30 or 40 lines of code to deal with the XML and to traverse DOMs and nodes and whatnot, so then return it back in the SOAP body. With XML serialization and web services, that becomes 3 lines of code and 5 lines of code, where it's just, I don't need to traverse anything anymore. I just instantiate an object that represents my XML, and it just radically changes how you can deal with XML and how you can deal with SOAP.
And also, doesn't that make it easier for like legacy-based systems to add SOAP and XML support for them?
I would say so. If I have a system now, if let's say I built a application a year or two ago, or I'm even building one now, and I don't really think I need to use a web service, and let's say I'm a news vendor. I have a website that is gaming news. It's like an online magazine. I build this with, say, ASP.NET, and it's very great web pages, and people just love it. And then one day, some gaming vendor out there who has a website says, we would love to show your headlines on our site. That would be great. And you think, oh, wow, what an opportunity. And then you realize that in all of your code, you've never done anything to expose your list of headlines that you have on your front page to anybody. And so you say, well, how am I going to do this? And you look at your code, and well, right there is some code that traverses the headlines that you display on the page. Maybe you can just expose that code as a web service. Put the web method attribute, create an ASMX file, and then tell your partner, hey, do you understand SOAP? Do you know all about that? And they'll say, oh, sure, we have this SOAP API, maybe .NET, maybe not. They can then call your SOAP service and get your list of headlines. You haven't changed anything about your code. You just have exposed it. And we're turning it into XML and industry standard SOAP so that there's nothing special that has to go on. There's no code that you have to give them. And now you have this partner-to-partner integration that you didn't have before.
And from a discoverability standpoint, it's really easy then for you to pass that information across other people, and they can just discover how to take and connect up in the same way your proxy code.
Exactly.
Knowing the server and the service says what's going on there, and it created the stub proxy.
Exactly. With Beta 2 and versions after that, especially, that ASMX page, WSDL, if they put in that URL string, they will get a description of the exact SOAP operations that your service supports and the exact schema for the XML sent and returned. They can use that with whatever tool, whether it's .NET or some other platform, to take that WSDL and then understand the SOAP service and discover and see the structure of your data for how you're sending, say, those headlines back and forth. And it's all very simple because it's been described for them.
Well, I'm sure we've got some programmers out in the audience there that, after hearing you talk about what SOAP can do for them and even seeing some of the examples you have, are now, anxious to start working on this. What are some good tips you can give these people about where they can find information, how to get started actually implementing some of these SOAP capabilities?
That's a good question. There's the very first place is the SDK. There's a quick start within the SDK that covers ASP.NET, that covers Windows Forms, and then has a How Do I section. In the ASP.NET section and in the How Do I section, we talk at length, and there's lots of samples taking you through very simple web services to much more complicated web services. There's also a section on the XML serialization to help you understand how all of that works correctly. I would say the very first thing somebody who'd wanted to build a web service with .NET should do is go through those quick starts. If they want to dig deeper and find out more about SOAP and find more about WSDL and XML and what's going on there, if they go to MSDN, msdn.microsoft.com/net, there's a SOAP section with a lot of great articles and a lot more that I know are coming along the way. There's a white paper there that myself, Jonathan Hawkins, and Pranish Kumar, who are PMs also in the developer division, co-wrote about how we use SOAP within .NET and how we use SOAP within Visual Studio.NET that describes all the various options and is another really great introduction to these technologies.
Okay, I'll make sure I put links to those specific articles at the bottom of the transcript so the users can go there and check and go directly to these articles that really help them out. And if we come across any other links that we think are important, I'll take and make sure I put them there too.
Okay.
Well, thanks, Keith, for joining us. I'm sure the developers enjoyed hearing and seeing what SOAP can do them. That was a fairly easy and simple and straightforward example there. Well, so hopefully that gave you some information that allow you to take and understand how SOAP can assist your applications in connecting across the internet to other systems, to other servers, to other services, and be able to expose a big world out there for you to consume information and provide information to other people. Well, don't go away. There's more of the show coming on, so stay tuned.
This is our 10th episode of the MSDN show, and we thought it'd be fun to take you a little behind the scenes and learn a little bit about how the MSDN show is filmed and the people behind the show. With me today is Bob Snyder. He is senior producer of Microsoft Studios, and he's been with us working on the show since the first episode. Bob, welcome. Thanks for joining me today.
Thanks for having me.
So tell me a little bit about what it takes to film the show.
Really, what it boils down to is getting the right content for the right audience. So once the audience is determined, then we can kind of craft the content. Actually, Robert does most of that. The cameras, the lights that we have here right now, we're in a control room at Microsoft Studios. If we don't have content, we don't have a show. So it's just like regular broadcast TV. We usually shoot all the segments in one day, edit them another day, and but it takes Robert, I'm sure, countless months and hours to wrangle the content.
Of course, right. And besides the MSDN show, what other type of productions do you work on at studios?
Most of what I work on is the live stuff, live broadcasts, live webcasts, product launches. I did quite a bit on the Windows 2000 launch, Windows Millennium launch, the Exchange launch, Enterprise launch. And I really love live stuff. And it's kind of a dying art. Of course, I'm an old guy, and that's why I can say that. A lot of people get pretty nervous about live stuff. And I'm just the opposite. It really energizes me.
More at stake.
Yeah, more risk. And I'm a risk taker, more or less. But it's fun to be able to get 50 people going in the right direction, in the same direction, and really pull off a successful show. It's a lot of fun.
So how long have you worked for studios, and tell me about a little bit about your background. I'm sure you've done production elsewhere.
Been in production about 30 years, used to do radio and TV commercials. I stopped doing commercials after I hit about the 17,000 mark because it's way too many for one guy. I've been at Microsoft as a vendor. I was here for about 7 years, and I've been an employee for about 7 years. And I became employee because I thought back in those days people were pretty random, and they were spending a lot of money and doing a lot of things that were kind of duplication of efforts. So I decided I'd become an employee and would just fix it. And I'm still trying to fix it.
So what do you like to do outside of work? I see in the background we have some rodeo footage. So I take it that's applicable.
Rodeo is one of my, it's kind of a side passion. I grew up on a farm. I spent summers on a farm over in Clue City. And the people there are so real and genuine, and they work so hard. You see these farmers out there with no support, and it's just them against the elements, and yet they love every second of it. And part of that farming life is horses and cows and rodeo and the whole shmear, and ranching as well. So I kind of grew up involved in the rodeo, small town rodeo, and have been there ever since. And I sponsor some rodeos now, and always go to the National Finals Rodeo in Vegas, and have the opportunity to hang out with some of the big names. And they're just regular guys,
Yeah.
just like everybody else.
Do you ride horses yourself?
I used to. I'm a little smarter than that now. But,
Why is that?
it's just you're up so high. You know? And no, actually, if I had the time and the place, I would probably have several horses.
It's a lot of work.
But it is a lot of work. It's just like having another kid, you know, or several kids.
Yeah.
So,
So Bob, you've talked about your professional life and your rodeo life. What about your family life?
well, I've been married 27 years. I've got 3 great kids. They're almost grown now. Andy's 18, Kelly is 21, just got married. Brian is 24, working at an ad agency in Seattle. Brian actually is the one who helped Robert make the shell for this MSDN show and made all the little bells and whistles work. It's way beyond me, so I'm glad that he got his intelligence somewhere. It wasn't from me. But they're great kids, and I wish I had a dozen more, because kids are, I just borrow kids all the time. Legally, of course, like parents know and everything, but usually once a spring or a summer, I'll take 10 or 12 neighbor kids and we'll go camping without their parents and stuff and just hang out and smoke cigars and stuff. It's great. You know, the 6-year-old hadn't quite got it down yet, but she's getting better.
Well, Bob, thanks for taking the time to talk to me today.
You bet.
It's been great.
Thank you.
Thanks for joining us for another episode of the MSDN Show. On this episode, we hope you learned some things about soap that'll help you in your own development efforts.
And stay tuned for the next episode of the MSDN Show, where we'll talk about even more exciting details of .NET technologies.
And until then, we'll see you on the web.